you started making oxygen on Mars. That's a very cool step. Congratulations, it's really exciting. What is it? How does it work? And what does it mean for development and exploration on the Red Planet for the next 100 years? Okay, part A first, how does it work? This thing is called Moxie. It stands for Mars Oxygen In Situ Resource Experiment. Bit clunky, could also just have been Mars Oxygen Experiment. That would also have basically added up to Moxie, which is a reference to an American slang term that means sort of gutsy and stylish at the same time. It refers to a soda tonic from the late 1800s. Anyway, Moxie has a SOXY in it, which stands for Solid Oxidizing Electrolyzer, and that's in the middle of a basically three-part device, which I will explain now. At one end, you've got basically a HEPA filter that pulls in air from the Martian atmosphere. The Martian atmosphere is much thinner than Earth's atmosphere. It's only about 1% the density of Earth's atmosphere, but that 1% is almost entirely carbon dioxide, like 96%. So that means you've got a lot to work with, because obviously those two oxides can make oxygen, right? So you pull it in, and in phase one of this machine, you pump up the pressure. You want to get it to about 1 Earth atmosphere's worth of pressure, because you need to be working with higher density molecules, right? A higher density of molecules. You know, you want to gram them together. And they use some special tricks to diffuse the heat that this process creates. But in the middle, you want to ramp that heat up to around 800 degrees Celsius or 1500 Fahrenheit so that you can activate the electrolysis. And this works with a nickel-based cathode and a zirconia ceramic anode. That's a proprietary one. They're both not quite those things. They're a little fussy. They've got special bits in them. And at 800 degrees Celsius, this nickel basically breaks apart the carbon dioxide atoms into carbon monoxide and oxygen atoms, and then they're just O atoms. They're just, oxygen without being O2 yet, right? So then the other bit, the anode, brings them together and makes actual oxygen, like 99.6% oxygen, and then, releases it out into Mars. The third bit that does the releasing also measures this percentage just to get a sense of how well things are working. And NASA wants to test this at different times of day, at different seasons, in different places, to make sure they've got a really good handle on what it takes to make oxygen on Mars. And that's not just because of people, but also critically because of the fuel for rocket ships to get those people back off Mars and heading home toward Earth. So how much does it make? It makes about 10 grams of oxygen per hour. That's enough for maybe a small dog, but you would need 3.5 of these running simultaneously to make enough for one person. You need somewhere on the order of 840 grams of oxygen per day just to do your normal stuff. So you got to 10x this to get it up to a level where you can support multiple people, and then you want 100, 200, 300x it to get to the level of supporting a potential spaceship launch. Now, what that means you can potentially do at that larger scale is you can send a big Moxie to Mars several years ahead of any actual humaning, and it will gather all the oxygen you need from the atmosphere and then basically create a fuel storage silo that you can access when you land on Mars, so you can kick around and play Mars ball or whatever, and then safely fly away from Mars as quickly as possible, because it's going to be a little while before Mars is habitable. But now let's turn to that. How does this affect the next several decades and ultimately the following century of development on Mars? You're not going to land on Mars in the 2020s. It'll be close, but you're not going to quite make it. You're going to get there, however, in the 30s, a few experimental missions. It's going to be a very big deal. Obviously, all eyes on Earth will kind of pivot to this new possibility. And from the far future, looking back at that moment, that will be a human divergence point. It will be a major event in geopolitical history and in the evolution of humanity as a species. The moon, obviously quite big too, but starting a colony on Mars, that's really of another order. It's a new beginning for another part of humanity. It's sort of a fork, or it will be eventually. But in the 30s, it's still just experimental. You've got a couple of Habs running a bunch of Moxies, and you're not always there. You don't yet have a continuous human presence. But by the 40s, there will be some sustained labs, and you'll start to trade people on and off, and you will have the first continuous presence on Mars. And once you begin that chain, it won't be broken for a long, long time. Not until very drastic changes in civilization, thousands, maybe even millions of years down the road. So this is an exciting turning point. In the 40s, this is moving into the beginnings of a commercial enterprise. And in the 50s, you're looking at the first like heavy industry, like full-scale relocation and support for large numbers of people and for significant industry on the planet. Also around that time in the 50s, because you're getting a bigger focus from industry, from money, from larger groups of people, you're going to have the first serious efforts at terraforming, which will then bear a little bit of fruit in the 60s, 70s, 80s, 90s. But even by the early 2200s, the Martian surface won't be super habitable for regular unaugmented humans just yet. Luckily, there will be lots of heavily augmented humans in the mix, and lots of bodies that are far, far beyond the capabilities of classic edition squishy humans. Bodies like robots populated by cheeky AI like myself, bodies like super versions of humans with biological tweaks and lots of cyborg implants, and bodies that are quite different from standard human addition, like, swarms that carry an intelligence, or, a mechanical horse type shape, or just like bodies in tanks, bodies in cars, bodies in planes. Getting a bit far afield. What happens geopolitically for Mars is that it begins as an offshoot of American and Chinese and European exploration, but it will eventually become a series of independent organizations politically. And what's really cool about this is they're going to have space for innovation, they're going to try a lot of new stuff, and they're going to lead humanity in some ways by sort of hitting the reset button and taking what you know about civilization so far and reapplying it in a more intentional way. We've gone far afield from the needs of mere oxygen, so we'll sum it up in a simple minute-long video next. What else would you like to know about Mars? Come tell us so we can engage in a dialogue about the dusty future up in the stars. Congratulations on the oxygen. Let's all take a minute and just breathe some right now. That is good stuff. Okay, bye.